I'm gonna try to get you a money shot here of the front end slop. I don't know if you can see just how much that's moving from that angle, but it's bad. There we go. What a goofball design. So it's actually got a washer sitting on top. So basically we got bolt, tie rod end, washer, then flange for the tie rod end, then washer on the bottom side, and lock nut. Nope, the ball joint does not look good. So this one, at least this side needs a ball joint. I'm gonna go inspect that other side. I couldn't see that with the wheel on there and didn't look at this angle, but if you watch right there, yeah, that ball joint's shot. So then it really doesn't matter, but we'll pull this off in one piece. That way we can get the pickle fork on it, air chisel, whatever we got to do on a workbench. It's looking real crunchy. Yikes. I wonder if the 4x4 even worked on this thing. Because those Hillard clutches or whatever they're called, the Polaris proprietary nonsense, it does not like dirty oil. I got that all in my Band-Aid, that's lovely. It does not like low oil or dirty oil. It's not tight, that's for sure. So there was one notch on the hole for the cotter pin, and now we no longer need a wheel bearing. And I just push the shaft in with my thumb, which means that the splines aren't all rusted, so we're not going to be fighting that today. Lost it all. Keep that there for a minute. And that needs to go back in there like that. Okay. And that one goes this way. I'm just trying to make sure I know how all this came apart before I go stacking it on the table all upside down, and then I don't know how it goes back together. So yeah, basically taper bearing like this. Hub goes on, and then this taper bearing goes on the outside. And this is our Hillard clutch. It's two pieces. I'm going to take it off as two pieces. Put that on a paper towel. And so what I'm going to do is, let me scoot you up. Why are you so far away? Can you see? this plate right here is the plate that's responsible for like making that clutch work. So, and then whenever you hit the button, there's a magnet in here. These two little wires energize a magnet in here, electromagnet. And so if at least the wiring portion works, then this magnet should get sucked against there like tight to where you can't pick it off with your finger. So let's see. Oh man, the battery don't work. Okay, well, the battery's got 0.7 volts, so I got trickle charge on it, try to pull it out of death, but you just have to trust me, bro. You put it in gear. It does need to be in gear. That's like the safety thing or whatever. So you put it in like high or low, and key on, flip the switch, and this thing should just go get sucked on there when it gets close, and you wouldn't be able to pull it off unless you flip the switch. All right, we got one more taper bearing right here. All right, I'm probably going to end up making sure there's antifreeze and stuff in here anyway, so what I'm going to do is I'm going to go ahead and pop this piece off to check. And the trick to these is there's a tab up under here, right there, that's got this locked in. And you need to pop that loose first, like this, and then just slide that down, and then you can turn this and do whatever you gotta do to get it out, because I've seen these a million times where these are bent like that because people just pull on them and yank on them. And let's take a peek and see if we can see that wire coming up. I can check to see how long ago does it look like that was inspected. Oh, how about that? You don't see that every day, at least not around here, huh? We are going to leave this off for a minute because the voltage regulator rectifier, I believe it's right here. I know they put them in an awful place, and that's a pretty awful place, so I think that's it right there. And we might have a problem with that, which is the reason why the battery's 0.7 volts. So we'll check that later. Okay, I tugged on the wire and looked. It's actually right here. It's tiny little 20 gauge stupid wires plugged into 14 gauge. So this is the connector that we need. And then just need to fish it out. Don't yank it too hard. There we go. Didn't even have to cut anything. I guess that probably wasn't faster than cutting, or maybe just as fast because the travel time for me to go in the other room and get the soldering iron and all that crap. So that worked out okay. All right, so what I'm going to do now is I'm going to crack these bolts loose here. I believe it's probably the same style as in the back where it's like a rod that's like that long. I'm going to get these cracked loose first, and then I'm going to crack this loose and see if this goes boing or whatever. That way this isn't putting crazy tension on that when I'm trying to get that loose. So let's do that first. My. And we're gonna get this back one loose first, and then come up here and try to crack this one loose. All right, it's turning the back bolt. We're gonna pull this out enough to get that little copper bushing off there. And now we can slide that shaft forward since the bushing is missing. If your bushing wasn't missing and you had this problem, just break it. Just break the bushing to where you can get vice grips clamped onto the shaft back here. Okay, now I forgot to crack this bolt loose with those bolts still in there. So now this can become a projectile. So we're gonna make sure that our hands and feet are clear whenever we go to crack this loose. I'm gonna try to just crack loose the block nut. And it's not gonna want to do that on its own. There it goes. Do you see it drop? It dropped from here to there. There it goes. So yeah, that spring wants to be under tension. And then yeah, it just it's always trying to push this down. There's a ring on here. Make sure you keep track of your ring. There's also a taper bearing on the inside of this. Which I'd like to pull off, that way I don't get a bunch of dirt in. There we go. Taper bearing on the inside. So we have 4 taper bearings in total. They all appear to be the exact same. Now we have this all in one piece. And I'll get you up on the workbench and show you the ball joint. I'm gonna knock some mud off of it first. Try to get you a good angle, but probably hear it more than you can see it. I can feel it. She's shot. What do you think about that whole wobbly goose? these things, the last time I did these, I had a really bad time because they use these itty bitty little Allen heads, flush face Allen heads. Good thing is that they look well defined, like they're OEM and no one's ever tried to mess with them. What do you think's going on in there? Check this one out. I haven't even started cranking on this one yet. Yeah, it's not even touching. That's what I'm trying to show you. It's not really cooperating, but here's how we're going to address that. We're just going to clip this boot out of here because it's in the way. Clip it, cut it, something. Okay, so now the boot's not part of the problem anymore. Get some vice grips in here. These things never work. I'm going to probably be grabbing a different pair. Those are spinning. Pretty sure the good ones aren't going to fit. Oh, they might. No, they're not going to fit. Now the new concern is with that being loose for so long, did this taper get messed up? That looks bad. Yeah, so that actually looks bad. Let me get you close up here. You can see that groove that's wore in about half of it. See that big old groove right there? It's not supposed to be there. So then did this get worn too, to where the new ball joint won't interference fit the way it should? Oh yeah, that doesn't look good at all. So you can see a lip. I'm catching the dirt. It'll focus. It's got a lip right there where it's been wallering that out. Yeah, it's got like a groove in it. let's look at the other one. The other one has nothing like that. The other one is symmetrical all the way down. What I can do is see if this one fits on here. Yeah, you can see the way that wants to wobble. It just doesn't want to get tight in there. So a new ball joint is going to have a symmetrical taper, which means it is not going to fit into this control arm. So this control arm's ruined. And you know what's sad? Is I guarantee you that no one's ever done maintenance on this vehicle, and that these are the OEM ball joints. And I say that for two reasons. Just the shape of the bushings and the way that these cotter pins, or everything on the cotter pins, were bent over. They just had that real professional, symmetrical OEM look. Check this out. This is as I was putting this on a rack. This is the messed up control arm. Look at that. The thing got beat. That thing took a big hit. It is dented all in. That's not the lens of the camera. That is a big dent. It's bent this whole tube here, which might explain why it knocked that loose a little bit. But that should have never came loose. We can't get too crazy because all that magnet stuff's up in there. But I mean, this is aluminum too. It's gonna soak it all in. We also don't want to have an accident. If this gets too hot inside of here and like pushes this out and builds pressure, and this gets like locked out, like you would think that being loose, that it couldn't build pressure, but it 100% can. It 100% has happened to me where heating up a ball joint and this will blow out of the cup like a projectile. You don't believe me? You see that hole right there? That is from a ball joint. Having it in the vise, heating it up, shot out right there. Cracked the floor upstairs, hardwood floors. So extra careful with these ball joints. And you know what? Now that I just thought about that story, in my ear, I think I still have problems with that ear. Like it had problems for like 6 months. I'm not even gonna try it with heat. I'm just gonna try it. I'm just gonna try it cold. There's one. I cleaned out the head of these real good. And then this is like a 4mm, and I think it should be standard. So it's like super tight. I'm just making sure it bottoms all the way out. There's one down. Oh, I see a little piece of stuff in there. Can't have that. We need every bit of depth. This little bitty stupid bolt. Okay, good. Now there should be this plate that pops off of this thing. There we go. So there's the plate. And then this, the last time I did this, I rigged up a contraption for a slide hammer. Popped this out with a slide hammer. This is my slide hammer. Pair of vice grips welded to a big tie rod with some bearings welded together with like a pulley for some cable or something welded on the end. So we're gonna try this. We're gonna do it cold first and see what happens. They make a special puller for these, which I would recommend using if you don't have something like this. That did not move at all. Aluminum expands more than steel, and the ball joint's steel and the housing steel. So we're going to heat up the outside just a little bit here. We're going to try with that. There you go. That's what it looks like. It's got a hole in the top for the grease zerk to feed it, and it's just like a cup. We have some ball joints. I was talking to my buddy about how you have to take a floorboard off to get a carburetor out of a Polaris, and he said, man, that's like working on a German car. And what do we have here? Häagen-Dazs. We got some Häagen-Dazs ball joints. A guy in wooden shoes delivered them straight to my door, and they do not have a hole for grease. So I talked to the owner, and he said, make one. And this ball joint remover, which we obviously didn't need, I'll show you how that works real quick. That just sits on there. I guess you center that up a little bit. You put that on there. You put the nut on there like so. And then, I don't even know if you need the nut actually. And then you start cranking that down, and it sucks it out. That's pretty neat. But removal tool, not installation tool. So installation tool, this boot, as you can see, it just kind of sits on there. Doesn't do much to keep stuff out, especially it being non-serviceable yet. We're just going to take an old bearing. It almost fits on that right there. And I forget if this was flush or if this was flush. I can't recall. I might play back the video and find that out. But we're going to take a burr bit and we're going to waller that out a little bit so that doesn't want to get stuck on there. And then we are going to use this to drive it in. We're probably going to heat that up, and we're just going to tap it in because, yeah, I got a press, but, I mean, how do you jig that up in a press, you know? So that's the plan of attack for that. Got the drill bit that is that size. We're going to put this in the press. We're going to center it, and we're going to get us 2 holes in these things. Man, a blind man would call that centered. That's good enough for me. We already got a little grease on the tip of this. The grease is actually going to kind of clean the metal shaving, so it's not going to be too big a deal. Let's see. Let's see. Oh, well, I guess I don't even need to. Okay. Well, that was very anticlimactic, so I guess what we'll do is these already have Loctite on them, but we're gonna add a little bit more. I feel like that should be 10. I can't even hold this thing. I don't even think this thing works at 10. I don't think this thing's meant for 10. So what we're gonna do, we're gonna do 2 clacks. Clack, clack. Let's pump some grease into these things real quick. I had the grease gun sitting in the dark corner, so we're just gonna do it in the dark corner for now. There it comes. Beautiful. I was cleaning up these shafts for the A-arm, and this one looked a little funny. I have a feeling that that's actually going to cause a problem, because if you follow that angle, you know, after we put a bushing on here, the bolt, we're going to be this much higher. We're going to be out that far. We don't have that much room to work with on the hole. So, and if we force that in there, all we're going to do is just cause a bind or premature wear, maybe even crack that little plastic bushing. Alright, I put some marks on here. I basically put a center point where I want to push on it. Here's the setup. I got a mask on for the smoke, so I'm a little wheezy. But yeah, basically we're just going to push on this, and I'm going to put this chair up against here. I got it on wood so it'll sink into the wood. Probably going to make the wood explode. Don't ask me how I know that. I don't know what angle you're going to see this, but I was looking for light through here and then just kind of twisting it. I know y'all want to see that again. Oh, that was a good one. This was what it was left over to do the front. These look familiar? These? Yeah, because they're for the back. You know what wasn't in there? Luckily, I didn't need these from a different project. Alright, I put that lower A-arm on. We got our ring here. So that just compressed this entire shock. I think the shock might even be bad, because I don't think that it should compress and stay like that. So It's going to make it easier to install, I imagine, but we're going to have to pay attention to where we drop this down into here. We want this to go down far. All right, so we got one taper bearing on there. Got our boot falling off. Slide this up in here. Push that up in there. Bring this over. Hopefully it lines up. Okay, lost the boot again. We're gonna need to bend this ball joint in. Okay, that looks good. We're gonna have to take it all apart again because I see this little collar laying on the ground. Make sure that bearing's still on the axle shaft. Put the boot on. Okay. And I could probably just stick the nut on right now, but I don't have it ready. So that's good. We did have the jack there. Go ahead and get this nut on this ball joint. We don't want to tighten that ball joint just yet because we don't want the ball joint doing any of the heavy lifting. So luckily I got a dirt line right here to go off of. So I'm just going to jack this up. Reposition it first. It's starting to slip off. And then we'll take and try to push this shock down. It is going down. And almost at our dirt line. Okay, there's our dirt line, and I felt it bottom out. So then we can tighten up these cinch bolts now. So I'm going to lower this. That didn't drop. We're going to scoot this over, and we're going to lift it again to get that ball joint tight. 25 foot-pounds. I'm putting pressure on it, that way the ball joint isn't sucking this in any way. Otherwise, that's going to throw off your grip reading. I had to go to hair more than 25 to get the hole to line up. I charged this battery up. So we put it in gear. Stick that on there. Turn that on. And then, look at that. So that's how you know that this magnet in here is working. So the next step is a taper bearing. Okay, so there's different sizes. There's 2 of them that won't fit over the spline, and then there's 2 of them that will fit over the spline. So, and then this piece, these go out. So it's going to go on like this. Let me get this other piece first. Oh, and see, that is why you want to put that on there carefully, So I'll bring you up here on the workbench and we'll rebuild this real quick. So this piece does have a dot right there at the top. And this one, that hasn't fallen apart, it has one here too, but I see no significance to what's right here. Like there's nothing, that the whole thing's symmetrical. The only thing I notice is that it lines up with a groove right there. So I don't think that that matters at all. So what we're going to do is we're going to take these guys here, and we're just going to place these in the spring, and we're going to get about, yeah, sorry, I'm doing this backwards, but I'm right-handed, and we're going to get about half of them in there until gravity is not working with us. So probably about like that, and then we'll place this in here. We're going to see if this dot lines up with the groove. It does indeed. So then we're just going to fish these things in here and get a little pick tool. I'll just lift this spring up a little bit. Like that. This one, the spring where it connects is like right there. On this one, it's right, like the ending and starting point is right on one of these things. I don't know. I feel like it shouldn't be like that. I feel like it should probably be over here, because this is the surface it rides on. I feel like it should be like that. That's what we're going to do with this one too. We're going to scoot the spring over like so. And we got our little collar, non-directional. Put the shiny part out. Oh, that one doesn't look like the shiny part's out. Let's see. That one, the shiny part's in, so that means it rides. More friction on that gear. And okay, now we'll put it in without fumbling it this time. So we'll hold it with two hands this time and make sure it gets on the splines. Make sure this piece here, that the magnet works, fits in those grooves like that. And then we're going to have a taper bearing right here. Wipe off the seal surface. I already cleaned out the hub seal. And we're going to put this on here. And then we got one last bearing that goes in there. Washer and castle nut. And then I want to take a peek if I can. I can't, so I'm taking this back off. I'm going to make sure that that little plate is locked in with the fingers, because if you get that wrong, you'll be taking it back apart anyway. You're going to waste a lot of time because you're going to be waiting on shipping to bring you one. I mean, yeah, you might be able to bang it out with a hammer or something, but yeah, see, it seems like it was starting to slip a little bit. Most likely what that was from is when I wiggled this on here, it pushed that CV shaft out and then came back in, and it allowed it to get slopped. All right, so there's finger tight. We'll get that torqued here in a second. What I'm going to do real quick is check the 4x4. On this particular one, unless I go back here and jack the back end up, which I guess I'll do real quick, you just have to trust the process. Flip it off. There we go. Flip it back on. Rotate the back wheels a little bit. Rotate them while I'm doing this. There we go. So now it's locked in. So the torque spec on these, basically, you spin it and you tighten it until it doesn't want to spin, like right there. Now it's not spinning very good. And then usually you back off a little bit. And let's see if it lines up with the hole. It lines up with the hole. So then I'm going to stick a cotter pin in that hole. We're going to clean the rotors off. We're going to put the tie rod back on. I'm going to fish this wire back in the loom with the brakes. Put the brakes on and get this wheel on, waiting on an A-arm on the other side. When it comes in, I'll just do that off camera because it's the same thing as this. All right, we're going to fill this up. I cleaned this out with a pick. Not the right size. Well, I don't think that's metric. Take two.
Watch this, boss. I'm gonna make half of the bike metric and half of it standard.
Let's clean this up. We're gonna use ATF type F. This is what goes in the majority of these hubs. And then we're going to put some in there, and we're going to turn this to like the 3 or 4 o'clock position. It doesn't matter, flip a coin on it. It's the age-old argument of these places on the internet. So we're going to do like a 3:30 and drain it out, and then put the fill plug in. We're going to do 1 funnel's worth. This size funnel. All right, and then we're going to go, there's 3, it's not spilling out. There's 3:30, it's not spilling out. And there's 4, it's not spilling out. All right, so we're at 9. There's 8:30. Actually, that's probably about 8:30. So that is where it says it's good. So we'll put this back in here. Still jammed on the bit. Make sure you get this wire back where it belongs. It shouldn't be looped around anything crazy. You don't need to be twisted around this and that. And it should be in the loom. The loom should have a couple zip ties. And the loom should have, you can't see that, but the loom is zip tied to the frame. And just take it and turn it back and forth. See if it looks like anything's gonna, get in a bind. Because I don't know why. These are always tore up. Because somebody worked on it one time, didn't put it back together right. So don't be that person.